Today I have a Dell Vostro 153510, and this has come in for a problem with the hinge. We've actually got two of these in. The hinge has broken out of the top cover. This happens quite a bit with these nowadays. I don't know if it's because they're lighter, but that's the fault with this. So there's no electronic fault with it, it's just a physical fault. I'll cover that in another video. But what I'm going to do is I'm going to use the opportunity here just to take down a few settings on these, because we deal with a lot of these. So this is what the motherboard looks like. I'm going to take pictures of it and then we're just going to have a quick look around it. So this is my picture of the motherboard for the Dell Vostro 153510. What I'm going to do on this is I'm going to first bring you through troubleshooting the 19 volts main rail. We're then going to identify the power button and how that works, and then I am going to go around the inductors on the board and just point out what the values should be on each one. So we're going to start off with following the 19 volt rail, so let's do that. I've zoomed in on the section where the DC power connector connects in. So the first thing we need to do is we need to identify where the 19 volts comes in. So we have a schematic for this. So when I look at my schematic, I find DC connection on this. It's on what is it, page 82 of 121 on this. So we see that there's 6 pins on it. There's 2 behind it that are just grounded, but there's 6 pins right here, and if we see pins 5 and 6 are joined together and they connect to PL1, and that's the main 19 volt rail. So we can see that right here, PJP1 is here and PL1. So there's a jumper and an inductor right here. So we know that these are pins 5 and 6, so I'm going to mark them as such. So what we want to do when we're trying to troubleshoot the 19 volt rail is get our multimeter, put it in volts DC in the 20 volt range, and then stick our black probe to ground, which we'll find usually on any metal part, but I'm going to use it on the outer part of the connector here, and then start taking measurements with our red probe. So straight away we're going to measure right here. Once again, this is with our charger plugged in. So I place my probe to pin 5 right here, and I find that there's 19.3 volts here. So the first component in our path from number 5 moving along here, we have a number of capacitors that are there to stabilize the DC, but our first component in series is PL1, which is our inductor. So we need to make sure that our 19 volts is making it through that. So this is our inductor right here, PL1. So I place my probe to the other side of PL1 and we get 19 volts here also. So it's not immediately obvious where it goes from here. There's vias right here, but it doesn't show exactly where it's going, so I think it's going to the other side of the board. Now thankfully, because we have a schematic, we can take the guesswork out of this. I've marked on the board with a red line where the 19 volt rail is going. So as we can see right here, it's coming to this point right here, and then we don't know where it goes. It seems to disappear into the board right here. Although there are MOSFETs right here and inductors here, they seemingly are to do with the processor and are not our input. Now thankfully, because we have a schematic for this one, I can see that the next stage our 19 volts shows up is right here in the datasheet or in the schematic. So we should be looking for PQB11. So I had to look around here to see if I can find this, but it's not anywhere in the immediate vicinity of this, where we have it tracked down to. However, when I look down on the board, we find it down beside where the RAM is down here. This is actually PQB11, which is our first MOSFET. This is PQB12, which is our second MOSFET, and this is PRB02, which is our current sense resistor. We can see that on the schematic right here. So there's PRB11, there's PQB11, PQB12, and PRB02, and I presume that this then is our main 19 volt rail. So there it is, 19VB. So we go back to our motherboard, and that is it right here. So I measure right here and I find that there's 19 volts at this point also, and what we need to do now is to make sure that this MOSFET is on and that the 19 volts is on the other side. I've managed to find a datasheet for that MOSFET. So it's an N-channel MOSFET, and as we can see right here, Our 4 drain pins are on this side here, then we have our 3 source pins together and our gate pin right here. Now, as with all N-channel MOSFETs, if the gate pin is high, it's switched on. If the gate pin is low, it's switched off. So what we need to verify is that we've already verified we have 19 volts right here, these on our drain pins. So we need to verify that our gate is high, and then that means that this is switched on, and we should then have 19 volts right here. So I place my probe to the gate pin right here, and I find that there's 23.4 volts on this. And when I place my probe to the pin right here, which is the source pin, I find that there is 19.3 volts right here. So this MOSFET is switched on by the high voltage on the gate, and our 19 volts is passing from here, which is our drain pin, to our source pin right here. And we also find, obviously, that our 19 is connecting straight to our second MOSFET right here, which on our data sheet is PQB12. So we now have our 19 volts coming through the first MOSFET, and it's now showing up on the pins of PQB12. So we now need to verify if it's passing through PQB12. I checked the datasheet once again, and I can see that this is the product number of the second MOSFET. So if we check that out, that's a second N-channel enhancement mode MOSFET. So once again, we've got the 4 drain pins together, the 3 source pins together, and a gate pin. So if we see that on our sheet here, that shows up as our 4 drain pins are this side, our 3 source pins are right here, and our gate pin is right here. So what we want to do is see if this is switching on, and see if our 19 volts is making it through the second MOSFET right to here. So I check the gate pin right here, and on a gate pin I find that there's 24.3 volts. So it's getting the signal to turn on. And when I check the other side of the MOSFET, I find that the 19.3 volts is there also. So we're good to this point also. And next in line, as you see right here, is R010, which is our current sense resistor. If you look at our data sheet, we're now past our 2 MOSFETs, and in this section here, just before our power resistor. The next component in line is PRB02, which is our current sense resistor. The idea with this is that we measure before and after this resistor, and the voltage drop across this allows us to calculate what current is flowing through it. And on the basis of that, if it finds there's too much current, it can basically trip out the circuit and stop it from being harmed. But it is just a low value resistor, so we should be measuring the same 19 volts here unless this is blown up. So I press my probe right here, and I find that there's 19 volts here also. So we've now established that we're good to this point right here. And if we look at our schematic, we can see that this is our power resistor right here. So we know that we have 19 volts here. And as you see from the data sheet here, that then is referred to as plus 19 VB, which is our main 19 volt rail. So we've established that our 19 volts is good on this laptop. So that 19 volts then spreads out to all of the other secondary circuits, and you can measure that on the input capacitors to the secondary circuits. That is how I verify the main 19 volt power rail is working for this laptop. If we were not getting 19 volts right here, we would have found, when we go component by component, that the 19 volt is getting so far, and then for some reason, maybe it's getting to here and not getting to here. Maybe the gate is low. If there was a short on the motherboard, it would pull the gate for this MOSFET, meaning that you would have 19 volts on this side but nothing on this side. But obviously every scenario is different, but the best approach is to follow the 19 volts into the circuit like I've done here, and see how far it gets into the circuit. And then when you find that it stops at a particular component, try and work out, is the component faulty? Is it not being switched on? Is there a short on the motherboard that's preventing the MOSFET from switching on? These are the questions that you need to ask. The next thing I thought it would be useful to see would be just to see where the power button is on this. We had another one of these in a while back, and the power button was right down on this cable right here. But I went through these pin by pin, and I wasn't able to find one that was grounded when I pressed the power button. So again, I have the cheat here of being able to go to our schematic. So I searched for button, and when I searched for button, I could see right here that sure enough the button works the way they all work, that you just press it and it grounds this signal right here. So I then searched for this signal to see which connector it was coming in on. If I can highlight it here, oh come on. So I searched the schematic for this also, and as you can see here, it's pin 31 on this. So we need to identify what connector that is, and it's JIOB1. So when I go back to my motherboard, I look and I spot that this is JIOB1. Okay. Now what I did here was I marked off all of the pins to show so that I could easily work out which one was which. You can see right here, it's tiny. So pin 31 right here. So I got my probe and I measured that. I measured 2.9 volts on it. And when I pressed the power button on the front, I found that sure enough that was grounded, and that switched the laptop on. So the power button comes back to pin 31 on JIOB1. It's 2.9 volts. That's an always on voltage on the laptop, and when you press the power button that goes to 0 and switches the laptop on. Now on these laptops we have one main 19 volt rail, but that 19 volts is broken out to smaller DC voltages for use with different components on the motherboard. For example, the RAM requires 1.2 volts, so there's a secondary circuit to break down the 19 volts down to 1.2 volts, and for the USB, of course, we need 5 volts, etc., etc. Now, the easiest place to measure these secondary voltages is on the inductors. The inductors are the components that look like this right here. Obviously I've got text on top of it here, but it's a big grey component like this. So what I've done is I've done a whip around of all of the inductors on the board, and I've taken resistance measurements. I've measured them in diode mode. I've measured what the voltage is when the laptop is off and what the voltage is when it's powered on. So I'm going to do a quick whip around of that now and just show you what I find. This has the potential to be very boring, so I'm just going to quickly run through the measurements that I took at each of the inductors, starting with PLG2 at the top of the board. So I took a resistance measurement of 375 ohms. In diode mode it was 0.3. With the power off it was 0 volts, and with the power on it was 1.8 volts on this. If we take a look at PLG2, PLG2 is our secondary voltage for VCC in auxiliary. You can see here that it's the same sort of configuration for all of these. The 19 volts is fed into a high side and low side MOSFET, which are controlled by a voltage regulator chip. We have 19 volts coming in, and we have our lower voltage coming out, which in this case is 1.8 volts. Next we have these two inductors right beside each other here, and I took the same measurements from the two of these. There was a resistance measurement of 220 ohms. In diode mode I measured 0.252. With the laptop powered off there was 0 volts on both of these inductors, and with the laptop powered on I measured 1.6 volts. If we look up our schematic, we can see that PL01 is our VCC in, and you might recognize once again 19 volts main power rail to a high side MOSFET and a low side MOSFET here. These are controlled by another voltage regulator chip, which breaks our 19 volts down to our lower voltage. So that voltage in this case I measured to be 1.6 volts. The next inductor is PL501. I took a resistance measurement of 50 kilo ohms on this. In diode mode 0.4. With the laptop powered off it was 5 volts, and with the laptop powered on it was 5 volts. So I think this is my always on 5 volts. Let's just check and see. PL501, and sure enough that is plus 5 volts, always on power. In the bottom right of the board, first of all, just to explain this, the image right here, you can see I took a picture of the board and it didn't come out well in this section, so I've just sort of superimposed a better copy of it right here, just in case anybody's wondering. This right here, PLB01, I think B indicates battery, but the measurements I took from this were resistance of 13.8 mega ohms. In diode mode I measured 0.492. With the power off it was 12 volts, and with the power on it was also 12 volts as well. So if I check out PLB01, yeah, sure enough it's the battery. I'm not sure why it's on 12 volts. I'll need to just double check, make sure that the battery is actually charging. But you can see the same configuration once again. Our 19 volts main power rail comes in here. High side MOSFET, low side MOSFET, controlled by a voltage regulator chip. And we have a lower voltage coming out. But this is the inductor right here. And the values we took from that then are shown right here. In the bottom left of the board we have PLM01, which I presume is for memory. The resistance measurement for this was 415 ohms, in diode mode 0.082. With the laptop powered off, I measured 1.2 volts on this, and with it powered on, I also measured 1.2. Now 1.2 volts is the measurement for DDR4 memory, so I'm pretty sure we're going to search the schematic for PLM01 and find that it is the memory voltage. So PLM01, here we are, and yeah, plus 1.2 VP. So that is for our memory. Next inductor is PL301. So I measured resistance value of 15.6k on this in diode mode 0.326. With the laptop powered off, I measured 3.3 volts. And with the laptop powered on, I measured 3.3 volts. So I presume this is my 3.3 volts always on. If I look up PL301, yes, plus 3, always on power. So that's my 3.3 volt always on. Our last inductor is PL1801, which is this one right here. So I presume it's not coincidental that it's 1801 and I'm measuring 1.8 volt on it. But the resistance value is 3.3k when I measured on this. In diode mode, when I measured it, it was 0.282. With the laptop powered off, I measured 1.8 volts on it, and with it powered on, it was 1.8 volts. If we check it out on the schematic, it's this one right here. So it's PL1801. And that is 1.8 volts, always on power. I'm going to leave it there for the troubleshooting and note taking on this particular laptop for the moment. I was contemplating whether to put this up or not, because it's, it's a bit boring and it's not necessarily a repair. But the reason I put this together is so that I know these values in the future. I know where the power button is. I know where my 19 volts rail should be. And when I eventually get another one of these in with a fault, because we've quite a lot of these out in the field, I will at least have broken the back of, where to look to find a 19 volt rail, what the values should be on the inductors, which could be give me an indication if there's a short on a particular voltage rail. And I have a schematic for it as well now, which is really, really handy. I was contemplating whether I should post this or not, because it may not be of interest to anybody else but me. But I'm going to throw it up anyway, because I don't have any other interesting content. All I've got is broken hinges and broken screens this week. I have a video to put up about the broken hinges on these laptops, which I'll throw up later as well. But let me know what you think of these types of videos. If it's of use to somebody, I'll keep posting them. If not, I'll try and get some more interesting content. But please write comments down below and let me know what your views are on it. What do you think is good? What do you think is bad? And I'll be back with a hinge repair later on in the week. Thanks for watching. Like and subscribe.